Imagine standing on a beach and looking out across the ocean. The horizon seems endless. No matter how far you look, the water stretches beyond your sight. Now imagine something so much larger that the entire Earth is smaller than a grain of sand compared to it. That is the challenge we face when trying to understand the size of the universe. The human mind evolved to understand distances measured in meters, kilometers, and miles, but the universe operates on scales so vast that even our largest numbers begin to lose meaning. Yet through centuries of observation, mathematics, and exploration, scientists have managed to uncover just how unimaginably enormous the cosmos really is. To understand the size of the universe, we must first begin at home. Earth is approximately 12,742 kilometers in diameter. To us, that seems enormous. Traveling around the world takes many hours by airplane and months by ship. Yet Earth is only a tiny member of a much larger family known as the solar system. Our planet circles the Sun at a distance of about 150 million kilometers. Light, which travels at nearly 300,000 kilometers per second, takes about 8 minutes to travel from the Sun to Earth. This distance is so large that astronomers use a special unit called the astronomical unit, or AU, to describe distances within the solar system. As large as the Earth-Sun distance may seem, the solar system is much bigger. Beyond Earth lie Mars, Jupiter, Saturn, Uranus, Neptune, and countless smaller objects. The outer boundary of the solar system, including the distant Oort cloud, may extend nearly 2 light-years from the Sun. A light-year is the distance light travels in 1 year, about 9.46 trillion kilometers already. We have moved from ordinary numbers into figures so massive that they become difficult to visualize. If the Earth were the size of a marble, the solar system would still span thousands of kilometers. Beyond the solar system lies the realm of the stars. The nearest star system to us, Alpha Centauri, is about 4.37 light-years away. That means the light reaching us tonight left those stars more than 4 years ago. If we traveled aboard today's fastest spacecraft, reaching Alpha Centauri would take tens of thousands of years. The vast emptiness between stars reveals just how spread out the universe truly is. Space is not crowded. Instead, stars are separated by enormous oceans of darkness. Our Sun is only one of hundreds of billions of stars in the Milky Way galaxy. The Milky Way is a giant spiral galaxy stretching roughly 100,000 light-years across. If you could travel at the speed of light, it would still take 100,000 years to cross from one side of our galaxy to the other. Within this enormous structure exist countless star systems, nebulae, black holes, and mysterious regions that humanity has barely begun to study. The sheer scale of our galaxy alone is enough to make Earth seem insignificant. Yet the Milky Way is not the universe. It is merely one galaxy among many. Astronomers estimate that the observable universe contains hundreds of billions and possibly trillions of galaxies. Each galaxy contains millions, billions, or even trillions of stars. If every star were represented by a grain of sand, the number of grains would exceed the number found on all the beaches of Earth. The universe is not just large, it is overwhelmingly vast beyond ordinary comprehension. Our nearest major galactic neighbor is the Andromeda Galaxy, located about 2.5 million light-years away. When we observe Andromeda through a telescope, we are seeing light that began its journey before humans even existed in their modern form. Looking deeper into space is literally looking back in time. The farther we observe, the older the light becomes, allowing astronomers to witness earlier chapters of cosmic history. As telescopes improved, scientists discovered that galaxies are not scattered randomly. Instead, they gather into clusters and superclusters connected by gigantic filaments of matter. Together, these structures form what astronomers call the cosmic web. This web spans the observable universe like a colossal three-dimensional network. The largest structures in existence stretch for hundreds of millions of light-years, dwarfing entire galaxy clusters. But how far can we actually see? The answer brings us to one of the most fascinating facts in astronomy. Because the universe is approximately 13.8 billion years old, many people assume we can only see 13.8 billion light-years in every direction. However, because space itself has expanded while light was traveling, the observable universe is much larger than that. Today, the most distant visible regions are about 46.5 billion light-years away in every direction. This means the observable universe has a diameter of roughly 93 billion light-years. That number alone is almost impossible to comprehend. Imagine traveling at the speed of light, the fastest speed allowed by physics. Even then, crossing the observable universe would require 93 billion years, nearly 7 times longer than the age of the universe itself. Such scales stretch the limits of human imagination. Yet there is an even bigger mystery. The observable universe is not necessarily the entire universe. It is simply the portion we can see because light has had enough time to reach us since the Big Bang. Beyond this cosmic horizon may lie vastly more space. Some scientific models suggest the entire universe could be hundreds, thousands, or even infinitely larger than the observable portion. The truth remains one of the greatest unanswered questions in science. The reason the universe appears so immense is partly due to a dramatic event called cosmic inflation. According to modern cosmology, a tiny fraction of a second after the Big Bang, the universe expanded at an astonishing rate. Regions once smaller than an atom rapidly grew to astronomical sizes. This inflationary period may explain why the universe appears remarkably uniform across vast distances and why space today is so enormous. Another surprising fact is that the universe continues to grow. Galaxies are moving away from one another because space itself is expanding. The farther a galaxy is from us, the faster it appears to recede. This discovery, first observed by astronomers in the 20th century, revolutionized our understanding of the cosmos. We do not live in a static universe, but in one that is constantly changing and growing larger over time. Scientists believe a mysterious force known as dark energy is driving this accelerated expansion. Dark energy makes up most of the universe's total energy content, yet its nature remains unknown. Because of dark energy, distant galaxies are racing away from us faster and faster. In the far future, many galaxies may become permanently unreachable, disappearing beyond our observable horizon forever. When considering the size of the universe, it helps to think about our place within it. Earth is one planet orbiting one star among hundreds of billions in a single galaxy. That galaxy is one among perhaps trillions scattered across an observable universe spanning 93 billion light-years. Every human who has ever lived, every civilization, every war, every invention, every dream, and every story has unfolded on a tiny world suspended within this incomprehensibly vast cosmic arena. Yet the immensity of the universe does not diminish humanity. Instead, it highlights one of the most extraordinary facts of existence. A collection of atoms on a small planet has become aware of the cosmos around it. Through science, mathematics, and curiosity, we have measured distances that no human will ever travel and observed events that occurred billions of years ago. We are a way for the universe to understand itself. So how big is the universe? The honest answer is that we do not fully know.